to be third time, I think, on third conference. Yeah, kind of different crowd, obviously, and but I met some really like famous people there, like this guy Jim Keller. He's the guy who was designing some of the I think AMD and Intel chips, like processor. Like he's very known in the industry, and now runs his own AI company. They build like accelerators for AI.
Cool.
But anyway, okay.
We are live on YouTube.
Say it again.
We are live on YouTube now.
Yeah,
The
Okay,
screen
okay.
just came up.
thank you.
All right. Okay, so I guess nobody else seems to be joining. So let's get to that RTP Bleed discussion, I guess. Sandra, do you have something to?
I could.
Yeah,
I could use the. So I got a presentation at ClueCon 2 months ago now. I could use some of the slides just as an introduction. What do you think?
yeah, just give us for the sake of our audience, I guess, and refresh.
Yep.
Kind of.
Let me do that.
What it is.
Let me put this on one screen, and then where's the other one? What am I doing? So this. Lots of shortcuts. Supposed to be practical. All right. So I can share. Fix that first. Now I can share my screen. So yeah, this was the presentation I gave at ClueCon. So it was called Media Security is Hard. At first I was going to try to cover everything, but realized, I only have 20 minutes. So I decided to focus on the core vulnerabilities that we keep seeing over and over again, which are RTP Bleed and RTP Inject. This is who I am. I run Enable Security, and it's me and Alfred. He's here as well. And we focus on voice over IP security and WebRTC security. And yeah, I use these sort of diagrams, animated diagrams, to show, the flow. It's not technically maybe 100%, but it helps with some of when trying to explain some of the attacks.
Yeah, it's a nice diagram.
I used AI for that.
All right, that's great.
So yeah, okay. We all know why media is attractive, I guess, everyone on this channel. And let's skip to RTP Bleed and RTP Inject. Now, like I said, we kind of find RTP Bleed and RTP Inject in most of our penetration tests, and also in some WebRTC penetration tests. But most people think, they've been fixed, right? So, and a bit of history, it wasn't actually, unlike what you wrote, Maxim, it wasn't actually found by me, but actually it was found by a friend of mine now, Klaus-Peter Junghans, a German hacker. And
wow, I didn't know that. Wow, okay.
Yeah, and this was found ages ago. He was doing things with voice over IP. Now he's a WebRTC guy, I think. But yeah, and I kind of rediscovered it during, while experimenting during some of our engagements. And I gave a presentation. That's, I think, where we met, Maxim, the first time at Camellia World. And Asterisk issued some fixes to their code because they had sort of tried to fix it in the past when Klaus-Peter Junghans had presented this, but they reintroduced the vulnerabilities some years afterwards. So, yeah. Anyway, and then I asked ChatGPT during the presentation. I don't know if you can hear the voice, but
Yes, the RTP Bleed vulnerability has been addressed in recent updates. For example, Asterisk has implemented fixes to take care of it.
I don't know if you could hear that, but
Yeah, it went through. Well, we
Yeah,
never
it sounds like
see.
things are in good shape now. As long as you're running the updated versions, you should be covered.
yeah. So I asked,
This is overly optimistic.
yeah. So I asked, so should we be okay now with this? We don't have to worry about it, and it says, yeah, it's being fixed. But the reality is a bit different, right? It's like we had discussed, Maxim, back in the days. It's a design problem, you could say, or a problem that is inherent of the nature of the internet and how RTP proxies try to fix certain issues with NAT traversal, network address translation. And although sometimes it is, we don't find it always. There are many cases where we find it, and there are cases where we find it in SRTP as well. But of course, I should first define what is RTP bleed and also define what I mean by RTP inject as well, and why do we kind of separate them. So we define RTP bleed as when a victim's media is redirected to an attacker-controlled host. And it happens because with NAT, the IP and the SDP and SIP might be essentially wrong. It might be the internal IP address. In most cases, that's the problem. And so what RTP proxies, like RTP proxy, like RTP engine, like Asterisk, and free switch try to do, media servers and so on, try to do is they try to learn the correct destination IP by watching for incoming RTP, where to send the RTP stream to. You have two legs quite normally in a call, and one needs to go to the other, and from the other one needs to go to the other. And it needs to learn the correct IP, and it learns it by just looking at the incoming RTP streams instead of relying on the SDP or any other, more safe way of doing it. And this means that there is no authentication in that case. And this is how it might look like. You might have the internal IP there on the SDP. But of course, the source IP is different. Here I take a sip. And yeah, we have an animation showing the same sort of thing. So you have the attacker sending RTP all the time to a range of ports, of course, on the media server. And if that server is vulnerable, then the attacker ends up convincing the RTP engine, in this case, that their IP is the correct IP to send to, because the attacker would be sending these RTP packets all the time. And wins a race condition, perhaps they're the first to send, or RTP engine gets their RTP first, and therefore it's useless that the users are actually sending RTP, because it's already won the race condition. The attacker has already won the race condition. All right. And what is RTP inject? And what's the difference? We define it as when an attacker inserts their own RTP packets into an active call. Now, the reasons for this is that, the server might have learned the correct IP of the users, but if it fails to validate that incoming RTP packets are from that same IP, then it will be vulnerable to RTP inject, but not RTP bleed. So you might see one and not the other. It's quite often that you see both in many environments, both vulnerabilities, that is. And yeah, it's interesting to separate them because they kind of require slightly different solutions, but one helps the other. All right, so this is the same animation, but the attacker is, but the server is vulnerable to RTP inject, and the attacker is sending all the time, and you can see the attacker's RTP packets taking over, and instead of receiving the RTP, the attacker is managing to send RTP to the user agents that are trying to communicate through RTP engine. Now, a bit of real-world implementations, how do they fare? We mentioned RTP engine because a lot of our clients use RTP engine. And we looked at these three different solutions. Now, RTP engine has a lot of different options that affect this. So it has these different learning modes, and it tries to learn the remote IP to send the RTP streams to. The default is the delayed mode, which is very insecure. Off is insecure, is secure actually. By the way, Alfred, feel free to interrupt me when I make mistakes. And this leaves the heuristic, which is kind of the recommended mode for most deployments. It prioritizes the IP addresses seen on SDP at SDP level, and then falls back to those don't match, falls back to just looking at incoming RTP streams and the source IP and port. It's the most pragmatic choice. But yeah, the delayed mode and there's another mode, the immediate mode, I think it's called, are vulnerable to RTP bleed because they decide after 3 seconds or after 0 seconds, let's stick with this IP, and the IP might be the attackers without looking at the SDP at all. Off trusts SDP only. So yeah, heuristic mode is still vulnerable, of course, because many users are behind NAT and they might not be putting their external IP address in the SDP, or the port might not match. But at least if the SDP IP is correct, maybe the user uses stun, you still have the first few packets that might bleed, where the RTP engine starts sending it to the attacker, but then it hooks onto the correct IPs of the users. And also there was a recent bug fix, which meant that before that bug fix in RTP engine, heuristic mode did not work as promised, essentially. So we always, as attackers, we always wonder its condition. And we were wondering why is that? And of course, we had a bug report to submit after a bit of analysis and discussion with Richard, the developer for RTP engine. Yeah, and then there's strict source in RTP engine. And this is something else. This is separate from the learning modes as such, but it is how you prevent RTP inject. So strict source, without it, you're always vulnerable to RTP inject, regardless of the learning mode. Almost always. There are exceptions with SRTP and so on. I did not go into SRTP yet. But the point is, in my opinion, you should always enable RTP strict source and disable RTP inject. And yeah, we have a table which kind of shows, before the security fix, what sort of results we had. So with heuristic, we still got RTP bleed and RTP inject, regardless, and with strict source, if you had no learning, that was the only one that worked. If you had the strict source flag as well, okay? If you didn't have the strict source, then you still got RTP inject. Now, after the fix, of course, you still had RTP bleed a little bit, but it was less than 5 packets, which can be acceptable in many cases. Of course, it still looks ugly on a report, maybe on a pen test report or a scan, but in practice, it tends to be okay. It might be even the attacker leaking their own packets, and that's another story. There's a lot of nuances with these attacks. So yeah, that was fixed 3 months ago. What about SRTP? Well, the assumption with SRTP is that it provides authentication. And therefore, you should not have this problem. And, the protocols, I mean, they do define authentication that you should, check the incoming SRTP packets and so on with the keys. But in the case of RTP engine, by default, it simply forwards SRTP packets without decrypting or authenticating them. And this is, of course, more efficient than doing it the other way. But the result is that RTP bleed still happens. The attacker can't decrypt the RTP packets if they are encrypted, if it's SRTP, but it leads to denial of service, which is a major problem, in my opinion, for media servers. It's, it's one of the main things that you care about, right? Delivering the media without disruption. So it still is a critical issue. And then RTP Engine, after our report, implemented a new flag called recrypt, which forces decryption and re-encryption of all SRTP traffic. So it does a kind of man in the middle, you could say. But this effectively authenticates every packet. And it does solve, for SRTP traffic, it does solve both RTP bleed and RTP inject. Yeah, and the same table with recrypt. Doesn't matter which learning mode you're using, you don't have these problems in terms of security. Now, what about the TLS SRTP? Well, this is in the case of WebRTC environments, right? That's where we see it mostly. And yeah, we do see environments that rely on Camelio and RTP Engine, and for their WebRTC applications. And these were previously also vulnerable to RTP bleed. Because first it learned the IP endpoint and then performed the decryption. Because in the TLS SRTP, RTP Engine specifically does decrypt and re-encrypt the traffic. It takes care of that. It puts itself in the middle. So yeah, the problem was that the logic was that first it does the learning mode and then does decryption. And the attacker could win the race condition, again, like plain text RTP, and get all the traffic. Now, interestingly, it was never vulnerable to RTP inject because the attacker's SRTP would fail the decryption stage and it would not get sent to the other endpoints, to the UACs. Now, This also had a security fix where the logic was changed so that first it does the decryption and then it does the IP learning. And this solved the RTP bleed and the TLSS RTP and RTP engine. So yeah, one has to not only upgrade to the latest versions, but and backports did not include all these new features, which are also security fixes in my opinion. But you also need to configure the way that you use RTP engine, maybe through your Camellia scripts, in a way that is not vulnerable. Free switch now, we're still working on a solution with them, but yeah, it does have auto adjust mode, which tries to handle NAT, and it does have some protection, tries to have some protection for RTP bleed and RTP inject, but there are problems with that logic, and they're not so easy to solve. So we're still working with the developers to get those fixed. We're not giving out information about that publicly at the moment. But yeah, there's that. And when it comes to, that was about plaintext RTP. When it comes to SRTP, it does not appear to be vulnerable to bleed or inject, but there's an additional issue, again, that the free switch developers are working on getting fixed. We also stalled a bit from our end as well. We need to pick it up again, Alfred, and get that fixed and get security fixes out there. So, and once those fixes are out, of course, SRTP would be the best way to secure free switch when you can use SRTP. And in my opinion, we should really be moving towards secure RTP in 2025, end of 2025. Then that would be the way. All right, Asterisk. Asterisk has flood protection to mitigate this. And it also prioritizes SDP negotiated IPs when available. But if that's not available, it has this logic where it discards packets from sources that send too quickly. And it seems, with testing this is not easy, okay? Testing this for this vulnerability. So it's a lot of manual work and so on. And we do think there might be ways to bypass this flood protection, but till now we didn't, in our limited time, we didn't manage to bypass it, except for in lab environments where we restricted the number of ports and so on and so forth, highly controlled experiments. So the point is it looks more robust than others, but we haven't seen the perfect solution when it comes to plaintext RTP, especially because of the nature of the vulnerability. The vulnerability, I don't think it can be really fixed for all cases, especially because of NAT. Now, yeah, so then we move on to detection and prevention. And yeah, something interesting, when I was at Camellia World, someone came to me from Australia and told me, look, actually, we've been getting these alerts on Showdown for our media servers. Can you take a look? And I looked at it and, looking at the data here, at the payload, that Showdown is this, Google for the Internet of Things, right? It scans the internet, finds stuff, and puts it on its database, and then you can search for it. And the first characters indicate that it's an RTP packet. And yeah, they are using RTP engine. So this is probably a case where Showdown was scanning for a completely different protocol. Do I have written down what are the protocols? No, I didn't put a note on my slides. But yeah, a completely different protocol is being scanned on this particular port, 20,002. And some RTP engine was handling a call during that exact time and started leaking the RTP to showdown, which shows it over here. So yeah, this does happen. And in terms of prevention, we have seen some solutions where people have implemented kind of a prevention solution which detects UDP port scanning that would catch not only RTP bleed and inject, but other attacks against media servers. It's not just UDP port scanning, of course, because you don't want to block legitimate users if you're doing automatic blocking with such a solution. So you need to be watchful, and you need to only block IPs that scan various different media ports within a short period of time. And it could be an effective way to detect and prevent this attack, even if they bypass your solutions. So yeah, in terms of checklist, I think upgrading does help, especially if there are security fixes for this. But it's not enough. You need to update your configurations if you're using RTP engine, especially. And SRTP should help, and it does help if it behaves as expected. Or if you're using RTP engine, you configure it in a certain way. And yeah, don't assume that you're safe, because we thought this was fixed in 2017, right? But when you test, you find different results than what you think, which is often the case with such vulnerabilities that are kind of interesting, protocol specific. Vendors say that they have fixed them, but they can't really fix them. So yeah, that's how you get in touch. I don't have any t-shirts or stickers online, sorry. But yeah, and anyone who's watching can subscribe to our newsletter, which we issue every month. It's not very spammy. It's very low frequency. Yeah.
No, it's great. Actually, it's great. I read it once in a while, and usually got good.
Thank you.
Good. Yeah, it's a great presentation. Thanks for putting it out. Yeah, the only small suggestion, I guess, for the maybe next time, if you got time, put some of the RTP proxy testing on the slides, so would be nice. Because I guess we use quite different algorithms on those learning sites, so it would be interesting. And as you remember, 2 years ago when you brought that DTLS thing, you actually tested and found it not affected by DTLS issue. But anyway, good. Yeah, as we discussed, this is kind of not really, I would not say design flow of the SIP itself. It's probably more like unintended consequence of the fact that we need to deal with NAT scenarios, right? So, which was never really considered when SIP was kind of designed. So, out of that fell. But I was thinking, just looking at it from more like long-term perspective. Sandra, as you said, yeah, moving to like more secure protocols definitely would help. But it's not only about using them, because sometimes people prefer like those simpler protocols for other reasons, right? Might be for I don't know, equipment vendor, it's easier to implement, or maybe it's like energy constraints or traffic constraints. So more security layers add more complexity. So
I
it's
agree.
like trade-off, and vendors kind of try to minimize for different but yeah, I put a little bit of thought into it over the years. I have a little presentation, a few slides.
Great.
Just let me. Yeah, I think we briefly discussed it. I think over private messaging, but I was thinking something along those lines. It's not really. Let me put it on the different screen. Hold on, sorry. You see that I'm presenting, right? Okay. This one. Yeah, I was thinking how we can mitigate it on a protocol level, right? So there is this RFC 5576, which adds SSRC media attribute into the SDP. So the originator of the call, in this case, Alice, could fill this in, and this would give SIP media and the media server idea of what the correct SSRC for the session, right? And then if we have this information, we can basically only limit to the not discovery to packets matching this specific SSRC, which would not eliminate it completely, that attack vector, because you can still kind of guess it, but with I think it's 32-bit number, so the like it will make it much more difficult to hit the correct thing. And then another thing that in this case we can do, this would also give it a little bit of attacker, a little bit of another attack vector would be Alice could send you known his own SSRC, and then if he knows where the Bob is, he can kind of bypass yours. So if, for example, if you want to pin the media, but he can pass through that ID, he can technically kind of bypass your media relay. So you probably want to conceal it. So when you forward traffic, you want to change it on the way out. So basically you have different one going out, and then on the return path, for example, Bob is not supporting this, so you don't get that SSRC. You can still secure that first leg, right? You can append SSRC on OpenSIPs or B2BA level and do the correct thing. And then on the RTP proxy side, this is how it would look like. I'm still already working on some changes to add some extra attributes for TTL and type of service. So I might just throw this SSRC control in. So we can basically, green here comes from endpoints, right? So we get port number and SSRC from Alice, and we fill generate random one for the outbound one to Bob, and we get port from RTP proxy. And then on return path, we basically don't get some, like in here, we don't have it from the Bob, so we just set outbound one to random and fill it in SDP, and yeah, basically get the port. So I think this is pretty simple, at least on implementation level, and so we can do on the RTP proxy side, we can do this enforcement and we do concealment for like changing this. And then OpenSIPs could have a logic to enforce or modify or add this attribute or pass it through, whatever, generate. Yeah, so kind of what I have in mind. as I said, I'm already working on some of those unrelated changes, but I will probably throw this ability in just for the future. But interesting, I said, would be if you what you think, maybe like raise it with like kind of RFC committee and see if we can, I don't know, shoot through like some kind of secure profile or something. Interesting. I don't know if you've seen that. Once upon a time, we actually invited Pavel Kuzevat, who is still he's pretty active on one of the guys who wrote the SIP spec originally to the YouTube, and he's kind of nice guy. So we might call him again and ask him what he thinks about this. Yeah, another thing that I was thinking in terms of mitigations, but again, this is nothing really in works. But if technically speaking, even with the plain RTP, we can do quite a lot of mitigation still. Like, well, for example, we can do some kind of sacrifice few initial packets, right, and have RTP consistency check, so you can check that you actually got the correct packet interval and you got correct kind of sequence numbers and all that. Because usually, if you build a scanner, it will just bomb all ports, right? So it would not do like correct, So it's like we'll prevent very simple scanners like that one, like Google. Whatever from picking this in, even if it's still vulnerable, but you will require a little bit more sophisticated setup. Another thing you can do, I guess, is to have some kind of blacklist, right? So if you see the same source, either match it by either host IP address or IP address / port number. If you see it, hitting a lot of unrelated sessions with RTP that get rejected, you can build it like put it into blacklist, so you just know that there's something going on. Yeah, and then you can also open few honey ports, right? And then if you get some packets to those ports, those will mean something like higher priority. I mean, more inputs to that.
In the same idea of honeypots, isn't the OS also able to block some sort of traffic? I mean, if it gets, I would imagine that like a dummy attacker, let's say, would flood all the port range, right? So some of them might be closed and some of them might be open. If they are closed, it can be detected and blocked. I mean, in a similar fashion as a honeypot.
Yeah. But on application level, I guess you can do more sophisticated stuff, right? You can check actual protocol.
And I was also thinking about ICE, because as far as I know, ICE shares the sort of a password in the SDP.
Yeah, ICE is for that reason. ICE is not technically probably should be vulnerable. That's what Sandra tested, right, 2 years ago, and there was some logic in RTP engine, but RTP proxy was not doing that.
With ICE, you should not have that problem. But there were cases where we found it was a problem still, like in RTP.
Actually, I had the other problem, like authenticated packets would not go through because of, let's say, bad implementation of the ICE password checking. But yeah, that's a bug. It's not related to vulnerability. That's why I'm pretty sure that ICE should somehow protect against this. But of course, ICE only makes you learn the correct endpoint doesn't guarantee that might not. I mean, doesn't guarantee that an attacker won't be able to spoof that.
Yeah, so spoofing is not part of the threat model, as in we think that if an attacker knows the source IP, the correct source IP and port, if it's plain text RTP, then they already have access to your.
Yeah, there are bigger problems.
They can anyway do RTP injection regardless. There's, so ICE, it's not meant to prevent that. When you have the multiplexing stuff, for the RTP stream, it only, I mean, yeah, it provides security up to a certain limit, but not for the whole. If your threat model says, hey, we cannot, we need to also protect against people who have man in the middle access, then you need the solution tends to be, encryption and integrity checks, like, SRTP in this case.
And what about asterisk attempts? I mean, if they addressed it and claim what's their approach, or how are they? Do you have any insights on that?
Mm-hmm. Yeah. So let me go back. Maxim, are you done from your?
Yeah, I think that's all slides I have. So if you guys have any ideas on how to
Back
further,
then to the asterisk slide, because I kind of skipped through that quickly. There it is. So yeah, they prioritize the SDP negotiated IP, just like the heuristic mode in RTP engine, you could say. And however, if the IP is internal on the SDP or some other IP different than the one that is actually sending on the internet or is being received.
It's not very likely for. Yeah, it's not. It happens, but it's not very likely. Yeah.
Yeah. What is not likely? That the SDP IP is correct or incorrect?
The IP is incorrect. Is different. Sorry, not incorrect. Different than. I mean, if it's a private IP, then most of the time can rely on the signaling IP, which is also provided for both RTP proxy and RTP engine.
Yes. And if you do that, you don't need to rely on incoming RTP packets. So this heuristic mode is not, would not be needed, and so on and so forth. So we shouldn't have this problem. But it seems that it is more, at least in certain environments, I think it is quite a high percentage of the calls. That's my impression, but I have not done sampling of traffic.
No, you're right. Most of the time, so if it's an end client, like a regular user, the signaling IP would be more or less the same with the RTP IP most of the time, unless you have some asymmetric routing that or different, your RTP engine or RTP server stay in different regions that get routed through different ASs or something like that. But most of the time it's the same. However, in let's say in relation with carriers or gateways, they usually provide the range of SIP addresses and a range of RTP addresses. Those ranges should somehow be communicated to RTP engine and proxy as well. I mean, this would also limit the window of, let's say, unknown IPs that might generate trusted RTP, at least on one side of the call.
For sure. So if you at OpenSIPs level, you tell it use the SIP IP, you tell RTP engine or whatever it is, RTP proxy, use the SIP IP. And I know that there are people doing this, just that our clients haven't been doing that. And actually, we were not, until recently, we were not aware of the solution. Okay, there are so many options in RTP engine. that it's,
Correct, and in RTP proxy as well.
yeah.
It's the same.
So this SIP address solution, I quite like it. We haven't tested it, to be honest with you, okay? But it should work. It makes a lot of sense as well.
Yeah, well, unfortunately, it's not going to work with like communication wall, because if you're a big carrier, you probably there are good reasons to have like a separate path for like RTP. Even if it's the same host, you might still want to split them by different IP addresses just to manage it easier. And yeah, some of our like biggest customers also just run it on separate servers, so that it's out of the question of having the same IP. So kind of.
But for
Yeah.
APC, it would work.
Yeah.
In cases.
But then it only works if you have like few known IPs. If you deal with like internet, if your customers with like IP phones,
yeah,
you're pretty much out of. Well, I mean, not and all that too.
But in most of those cases, the signaling IP is more or less the same with the RTP. That's probably 80%, I would say.
Oh yeah, I guess. But
that makes sense to me.
That's why it's difficult. But then you cannot really, unless it's 100%, you cannot really use it, right? Because you cannot really say, oh, like 10% of my customers won't be able to call, right?
Exactly. This is the biggest problem I had with the heuristic mode, and the question I wanted to ask Sandro, like how big of a percentage would you say that these, let's take some average tracking platform, right? Where do we put it? In the US? Fine. How big of a percentage of devices actually use this stun for the SDP IP addresses such that they are compatible with heuristic mode, right? Because like Max was saying, if you have this even 10%, 15% of your customers are using IP phones or whatnot, the PBXs coming from the NATed environments, and they use private IPs. All of a sudden, they will not work with the heuristic mode, or what happens, right? They will get no media probably.
No, heuristic mode should work, because that's the whole point, right? That heuristic mode is like a fail open system, you could say, where by default it tries to do the secure thing by looking at the SDP. But if that doesn't work,
I see.
it
falls back to just learning, latching onto the whatever IP comes, the media packets come from. Okay, gotcha.
But to answer your question, I don't think I can answer your question, because we are not a service provider. We just attack and then try to
sure
try to solve these things. But maybe
I understood.
Yeah, can answer that question. Actually, it's a very good. I would like to know.
Yeah, I understood that it's kind of a restrictive mode. But actually, what happens is that with heuristic mode, you can only secure so many devices which actually use the stun, whereas the proportion which doesn't, good luck, guys. You are vulnerable to RTP bleed. So yeah,
yes,
gotcha.
There's that. Now, and like I said, we haven't tested this, but what Razvan mentioned with the using the IP on the SIP instead of the SDP, that together with heuristic mode should cover more than just looking at the SDP. Okay, and that's what I assume. Of course, one has to run tests in realistic environments, live environments, A/B testing sort of stuff, right? And see, yeah, if this is true.
Also, I have a question to Max on the secure source ID and how that would work. Because it kind of feels like this ID is isn't it per session or maybe even per stream? It's not per device. Let's say I have a...
Yeah, it's per stream, yeah.
It's per stream. So how do you actually learn it from the middle side, right? How?
No, device.
From the SDP.
Yeah,
You have it in
so
the SDP.
device.
True. You get the first packet. I mean, there's no way the attacker can win the race condition that way. Okay, yeah, I get it. I thought it was a case of a race condition here, but it isn't.
No. Yeah, you get it in SDP. So whoever initiates the call will put it into SDP, and then you can pass it or change it, and then enforce it on media relay side.
Yeah, makes sense. This is the kind of solution on this level that I was thinking as well. But you know the protocol better, so you already knew there is a reserved field for this kind of stuff. Right?
Well, it's actually used in RTC quite a lot. I think it's part of SIP, like WebRTC kind of set of. Usually WebRTC includes all this info in there, whatever. It's not SDP, but whatever they use. So. Yeah, and for you, Sandro, by the way, you should really kind of look further into this, not in terms of this attack alone, but also how you can use it to penetrate like into further layers, right? Because technically speaking, even with like with SRTP, if the media relay has to decrypt all packets coming from unprotected sources, you might find some interesting extra vulnerabilities in which would be, you'll be able to put something more interesting on top of that bleed or inject than just middling with like media streams. Because especially with something like DTLS SRTP, there's a lot of various headers and a lot of processing going on with decoding it. So there might be some buffer overruns or something of that kind.
Yeah, there's a lot of attack surface for sure, especially once you go beyond, simple. I mean, it's not simple, but simple SIP and plain text RTP. Then the layers start adding up big time.
Yeah, and all of it actually. I don't know if you've seen it. We build for RTP proxy specifically. We build. I build those fuzzing integration, which actually fuzzes packets and send to like ice layer and SRTP layer. Kind of interesting. You can use Google Fuzzer to build those pretty easily.
Yeah.
It sounds pretty especially with AI these days. Just integration becomes a little bit easier even for somebody who is not hardcore like.
I have been vibe developing fuzzers lately, and it's fun.
Cool.
Sorry, I'm still stuck with the SSRC, trying to break it in some way.
Me
And it
too.
kind of seems.
Me
Sorry?
too. I mean, I have
I
a
know.
different question. Go ahead and tell yours.
I have,
then,
yeah, I
Vasant.
have an insight here. So now the question becomes, how many of the devices do not care about the SSRC, right, on an average basis? And they just put empty field or 0, because this seems to be the special value for the SSRC solution, right? So an attacker would always put SSRC 0 and still try to get in, right? Inject their RTP, get it injected. So would be interesting to get some statistics here. Kind of like in heuristics mode, right? There we had devices which are natted as a percentage and are stay vulnerable. Wait, let's just confirm this, right? If SSRC is 0, now the attacker has the most simple value to guess, right? 0.
Well, 0 is a special value. I think you
Yeah.
cannot really use it in. I think it's.
I don't think I've ever seen 0
I
SSRC.
mean, not 0, blank, right? You had it in the slide with Bob
Yeah,
sending blank.
you just
Yeah.
nothing.
Yeah, exactly, nothing. So this is the special value with this solution that
Yeah, but
probably leaves the devices
that's on
vulnerable.
the SDP, right, Max? I mean, in the RTP packet, you have a dedicated for integer that you need to use. You need to populate it. And well, if you put it to 0 or whatever random value, it's still a value. I mean, it's not like you can miss it. You may omit it in the SDP, right? But you have to put it in the RTP. It's part of the protocol. It's part of the packet. But I
There
have
is
a
like a bit. Mhm.
I have a different, let's say, concern. Let's call it, because RTP engine in RTP engine negotiation protocol, you specify the whole RTP, the whole SDP, sorry, and you have the SSRC. I wonder why they skip that check. I mean, it's clearly something simple to do if you have the information, right? I mean, you just whenever you latch, you check whether the SSRC is similar to what you have in the session and drop it otherwise. So I don't think it's like an implementation issue or bug, but rather I wonder whether it's a interconnection, let's say, limitation. And then I'm thinking about, for example, in we using some, let's say, SIP and RTP hacks using the media exchange, for example, we start injecting traffic to the same endpoint of RTP engine or RTP proxy, but from a different SIP endpoint. But that's because we want or need, for example, inject some media, and that would come with a different SSRC without properly negotiating it. Of course, the solution would be to renegotiate, reissue an offer answer and say, okay, I will now be sending from this SSRC or with this SSRC. But yeah, it's just a concern that probably, actually I've seen this. I've seen RTP flows coming from the same IP, same port with different SSRC without a negotiation. I think I've seen them using T48 or using for fax streams. So yeah, I mean, it's a long shot. Probably we should, of course, it's good for a proof of concept, but we should also see why, for example, why RTP engine doesn't do that, or probably there is a flag to enforce it. I don't know.
Maybe it does, maybe it does not. The problem is that nobody sends it. Like if you look at this attribute is not used unless you're on WebRTC site, right? So technically it's supported, but might not be. And Sandra probably never tested whether or not
Okay,
it
it's
works.
provided by the
Maybe
client.
Sandra can also look into this in his next iteration of this. So technically it might already be somehow enforced, but who knows? Yeah.
No, I don't think it is enforced. No, I don't think it is because, as I said, we had some we have some setups where we inject music on hold from different SSRC.
Oh
different,
yeah.
and it gets through. I mean, this is the default. Probably you can have. I didn't check the code, but you might
Yeah,
have
I,
a flag or
think you're
something
right. I think
to
you're
enforce
right.
it.
Especially we built that injection like ages ago. Like I think it was like 2008 or something. And yeah, I remember most of the devices don't care if you change it in midstream. Yes. But that's again, that's why I guess I think the most long-term solution would probably put it into some kind of RFC to.
I'm sharing this. This is from
Mhm.
RFC 5576. I don't know how to interpret this. Okay, if it actually means that one should also process then the such RTP that is coming from previously unmentioned the IDs.
Must be prepared. Yeah, handle such packets. So yeah, the same manner as packet from additional.
So there's that. I like the SSRC solution, by the way.
Yeah, but this is they try not to change kind of I guess
Yeah.
the behavior of SIP.
Yeah.
So this more like SDP level, right?
Yeah, I like the solution because it's still standard and everything is everything. We have everything there is just like probably a flag or additional check in case you. I wonder what's the use case they provided. I mean, I've clearly seen it, but like seen changing the SSRC mid call without announcing or re-inviting or anything. I don't remember exactly the scenarios.
Well, I mean, this is similar to what either you, Razvan, or Liviu was mentioning, where you just inject RTP for for early media, for example. We've seen those discussions,
Right. Yes.
and so on and so forth. I guess. So you would the injector would not, the legitimate injector would not know the SSRC and just uses any SSRC.
Well, yeah, but in this case, if we're building it from the ground up, the OpenSIPs technically would know that, or it could ask either renegotiate by sending some kind of update, or instruct media server to use a specific ID that it used before. You can save it right in like dialog parameters, right, Razvan? So it's technically solvable, not.
I don't think you know them all the time.
Yeah, but I mean, if you're generating it, if
You
you're
can
man in
generate.
the middle, yeah, you can basically say, oh, this outbound
For example,
session.
why not on the register? Maybe would be an idea.
Oh, no, that's call related. It's. Oh, but I see you. That yeah.
And then there's this one, and this is 8843. May start new SSRC values mid-session without informing each other about using the SDP SSRC attribute. I don't know. I'm just trying to find flaws, of course, in this solution, although I do like it, by the way. And this RFC is, yeah, this is, I think, is this used for?
Well, yeah, that's actually correct. I mean, there's a concurrency between you send an invite and the, let's say, callee receives the invite and it will immediately start sending and then send, let's say, the 183 or 200. So you might get a few packets if you get RTP before. Well, yeah.
Well, there's always this
Yeah.
concurrency issue, right? Because you technically
That-
should not accept from any IP until you get SDP, right? So you still need to learn something about the other side.
Yes, that's true. And for
We probably
provisioning, you
don't
have the
don't.
prac.
Yeah, yeah,
Yeah.
yeah. Probably won't do it for like NAT purposes. We accept just immediately, but that's just because we expect not in most of the scenarios. Yeah, yeah, but as I said, this RFC is not necessarily um, specifying the correct thing. It's just specifying the attribute that is probably needs to be just reused for this particular purpose. But yeah, it's just the idea anyway. So cool. All right. Well, maybe any other matters on this one. So how do we help you, Sandro, next time you're testing this? Definitely be interested in.
Hey guys, can I
Hey.
make a suggestion?
Yeah.
As for asterisk way of protecting, it's kind of very easy to break if we're talking about their flood algorithm. But it can be improved, and the same way we can address the issue in RTP engine. And in RTP engine, it will be even better because it has a kernel module, and it can see the traffic that comes to all the. I'm not sure, but I think it can see the traffic that comes to any socket, any UDP socket, not only the socket that application is listening to. Let me try to share my screen. I'm not sure I can do it right now, but I will try. Yes, I cannot. Let me try to do it different way. I can only share my Chrome tab. Okay, but the idea is as follows: the attacker need to go through the range of RTP ports one by one, and how they can break the asterisk flood protection. They can do 20 millisecond wait before loops when they kind of go through the maybe not 20 milliseconds because going through the range will take some milliseconds, but they can actually adjust the speed, the rate, they scan the range of the ports, and they can avoid this flood detection. But what asterisk can do? They can open a few kind of honeypots that asterisk will listen but not use them for media. Let's say asterisk opened 100 random ports, and if asterisk received from one IP address, if it received let's say more than 5 packets from the same source to different honeyports, that's a clear sign that somebody is scanning the system, and we can ignore any RTP packets in real RTP sockets, UDP sockets for real RTP traffic. And in case of kernel mode with RTP engine, I guess you can basically see you don't need to listen on the port as you work in kernel. You can basically see which packets come to which sockets. And you can see, on the other hand, the list of open sockets, open ports by RTP engine. And you can basically understand clearly if you see that some IP send random packets to random closed ports, but like it sends very little number of valid RTP packets to open sockets. You can calculate the range, the ratio of good packets and bad packets, and you can understand if it's a bad traffic or a good one.
Yeah, well, sort of. I mean, this kind of bad traffic might be legitimate as well. For example, application crashes and you can't send a buy, right? I mean, you receive, you delete the session, but you can't forward the buy, then you would get a lot of packets because the other entity didn't.
You will receive the packets to the same port. You will not receive the packets to the range of ports, and your ratio
yes,
is
that's
basically the number of scanned port to the number of open ports.
No, yes, I know. I mean, but your solution presumes that you either allocate a set of ports that should not be used as honeypots, like Asterisk does,
Yeah,
as you
that's
said,
for Asterisk. That's for us.
or somehow aggregate traffic on different ports or on a range of ports, and if that looks suspicious, then but again, that might be valid as well, because I mean, I'm thinking of a scenario where you have a gateway and you have a bunch of calls, let's say 10 calls, let's call them 10 calls with a gateway, and your application crashes exactly when it should have sent a buy. Probably sessions are deleted from the middle, either by OpenSIPs, either by timeout, and then that application probably recovers. Or anyway, I'm not saying it's not a good solution. I'm saying it's not that simple, and probably has to build some strong profiles in order to avoid blocking legitimate traffic.
Oh yeah. This is the main problem with any of those heuristic kind of solution. And
Yeah,
plus,
Can be like addition to heuristic solution. Like,
yeah, but this is also
there's
heuristic,
another
right?
layer.
Yeah.
That's just
we do have a
Or-
client who implemented something a bit similar to that, okay, which did block our tests at least, and seemed to not block legitimate users. Their solution runs every X seconds. I don't remember exactly what, but it had an interval, so it was not so neat. I also tried to do something on my own, again, vibe coding sort of approach. Did not yet manage to, but the concept kind of makes sense. It's not easy to do something and not affect, it's like anything with media, right? It's very sensitive, and you can, if you do have this interval stuff, right, where it's really cautious, then you have bypasses and vice versa. So but yeah, I'm sure you can do things at kernel level, and at different levels as well, even at just socket level.
we actually implemented proof of concept of this in with IP tables. It's very primitive, but it seems to be working. And in our case, we do not expect more than 50 RTP sessions from one IP address, and it's very easy for us. It can be, for us it works. Like, we know that if somebody uses more than 50 ports, that's an attacker.
Yeah. So my experiments that I wanted to do would be to try with IP tables and netfilter, or with eBPF, or with NFQ user space. And I'm sure one can invent other things as well. But I wanted to compare the different solutions, if any of them actually work. But yeah, nothing
You
yet.
mean tracking them at the different levels, or
Sorry.
you mean tracking or blocking them?
Well, first you start with tracking, of course, and then you want to block.
Okay.
I'm especially interested in this because we're always wondering, we do pen testing, right? And we don't do incident handling. So we're always wondering if the attacks that we find, the vulnerabilities that we find over and over again are actually being attacked. And there's, of course, the case of Showdown, which kind of proves, okay, this is really in the wild. But I don't think many companies are actually monitoring their media server UDP port ranges, right? Because there's so much traffic, you don't want to block any of it. It's very sensitive, like we said. But I'm really curious about, if a port currently is not being used by the media server software, right? RTP engine, RTP proxy, and so on, then any traffic coming to it might be malicious traffic. That's kind of the default assumption, right, that one would have. But of course, I understand, yeah, a call might still be going, and the RTP proxy has torn it down because, and so on and so forth. So I know it's not, but it's an interesting area to explore.
Well,
Yeah,
if
well,
you create some profiles, as Nikolai said, if you create some profiles that are custom to your, let's say, the traffic that then it's probably clearly feasible, but that's not easy to do. And yeah.
Yep. And of course, as we all know, I mean, there might be a customer who all of a sudden runs a campaign, and so on and so forth. So this changes your normal traffic today might not be the same tomorrow. Something I wanted to mention to Maxim is, do you guys want us to test anything? Because we might not, find anything, but it might be as you wish.
Well, if you want to retest that RTP bleed, RTP injection with different
We never
settings,
have not tested RTP proxy since 10 years. So if you have...
well, you actually did, right, with DTLS 2 years ago.
Yes.
So it was...
Yep.
Yeah, on that end, we spoke to Razvan about this just a few days ago. So use this opportunity. We basically added, it's not in release yet, but in the next release, which I will release soon, we'll have those easy to use Ubuntu Debian packages, which you can just drop in on whatever system you have, which would also provide like startup scripts and all that.
Nice.
So yeah, definitely if you can test that, and yeah, basically see how it compares. And also once we got the SSRC, we can look at maybe testing that as well to see if we can enforce it or if it's at all working. Yeah.
Interesting. Yeah.
Yeah. So okay, Razvan, do you want to talk a little bit about packaging? Maybe switch topic, if you guys okay.
Sure. So yes, I've been talking to Maxime, following a ticket on the OpenSIPs repository, and we've decided to put the RTP engine, RTP proxy, sorry, Debian package in our apt or in Yum. Not sure if you have Red Hat builds. but we should get Red Hat builds as well.
Oh, so you need Red Hat. Okay. Yeah, I
Well,
can pull that up.
RPMs, whatever.
So you're not
Um,
using Debian, you're using RPMs. Okay.
We use both. So we have apt.opensips.org where you find Debian stuff, Debian and Ubuntu, and yum.opensips.org where you find CentOS, Red Hat, and a few, 6 flavors, I believe, something like that. I can check. But essentially what we want to do is put RTP proxy packages in there so that people can easily come and just grab Debian and using apt-get install. And also for exposing the rtp.io, the librtp proxy library that Maxim has built in order to be used with the rtp.io module in OpenSIPs. Because we're currently skipping that module in compiling because we don't have the library available anywhere.
Yeah. But more in general, like how let's say we built our RTPO module. Somebody built like Shlomi built that Janus module, or somebody built some other module, and they need to put some libraries in there. What would be the kind of way to hook it up?
So currently the whole repository is managed on one of our private server, which it's actually a shell script that fetches, runs daily, fetches all the supported versions and builds Debians for it. The process itself takes around, it may take around 12 hours because we build for a lot of distros and we're not doing it in parallel. That's why we would love to benefit from GitHub Actions, because that would essentially also parallelize the building. And but actually this script was inherited from Nick Altman, our kind supporter that built everything by itself, and we just migrated it to our servers when he had to, let's say, to donate us the script, because he was handling the repositories like a few years back. Now we are handling them, and of course we didn't migrate them to GitHub Actions. I was actually talking to Shlomi and Nitzan at some point. They said they might be interested in doing that, but we didn't commit to it already. But it would be nice to have some sort of a GitHub action that builds the repositories in parallel to avoid the current, let's say, delay, but also provide the whole, let's say, all the mechanism to upload by other, let's say, other projects, for example, from Maxim using a token or something. It could easily push his own repositories. Also benefit of the notifications and triggers, because that's a problem. I mean, we are polling every single day and say, okay, we do a git pull, check whether we have that revision built. If not, we build another one. Otherwise, we just deploy it. And yeah, there's a lot. I mean, currently we are building for OpenSIPs, for OpenSIP CLI, for OpenSIPs Python package. I mean, that script is building for all these packages. I would love to, let's say, have somebody else do it for us.
Yeah. Well, if you need any help with that, let me know. I guess have a little bit of experience building. That's something I built for, like you guys know probably CC Cache project, the tool that helps you to cache compilation on. Yeah, I'm using it a lot in different projects since forever, pretty much. But they don't sometimes some distros get behind, so you don't get the latest version, and sometimes it's not consistent. So I build a little pipeline for them, which basically builds it on 1, 2, 3, 4, 5, 6, 7, about 10 different distros. So there's like usual ones like Ubuntu, but also for some of the lesser known like this many Linux, which used to build, which is required to build Python wheels, and it's a little bit different platforms. But for each of them, it also builds 6 or 7 different architectures. So you basically get about 80 maybe variants of CC cache in total built in one shot. Yeah, so anyway, I mean, we can easily do something like this for OpenSIPs as well.
Well, I'll have to check because, for example, even if we do it in GitHub Actions, we still need to upload them in our repository, which is we need to somehow upload them. So we need the protocol like FTP, so probably, or I think this is what's being used for Yom, and probably we can use it for Debians as well, just for uploading and triggering the, let's say, repository recaching or yeah, it's called caching. Rebuilding the repository. So I can probably look into setting that up so that you can, from a GitHub action, just whenever you have a new package, just push it using some tokens and run some hooks on our side to recache everything and build. Probably that's the first step, because we will need that anyways. Even if we migrate or don't migrate, we still need something for you to be able to push it. As opposed for me now, I will have to go through all the repository or the distros that you created and manually grab them and caching it. I would love to have that automated somehow.
Yeah, but another way to do it, I guess, would be just to run on simple cron, right? So it can run every day and grab the latest version, right?
Yes, that's true. But yes, it's true.
It's going like in the long runs, it might be more effective. Let's say you have right now you have only one kind of way, only one place to pull from. But later, some other projects might hook up, and then you know. Anyway, okay. Well, I don't know if you got some time to work on it. Let me know. I'm definitely interested.
Sure, I would love to find some time, to be honest.
Yeah, that seems to be the main obstacle these days. But yeah, all right. That's clear. Okay, well, anyway, I will add just preemptively. I will add some Red Hat packages as well. I guess.
I'm sharing you the supported platforms we have so far. So it's Red Hat, CentOS Oracle, CentOS Stream, and Fedora. But each of them has some flavors as well. I will send it to you.
Yeah, as long as they have some kind of official Docker image, should be pretty easy to pull through. All right,
Yep.
all right. Cool. Well, yeah, I don't have much else for the agenda. If you guys have something, I guess another thing that we wanted to pitch a little bit to you guys. I think Dima might have some slides for that. We are kind of slowly working towards organizing a conference maybe next year in Vancouver. So the idea was is that since we've been around quite a long time, we've been working, current number of customers is in a few hundred, and over the years, number of companies we've been working with in the field is probably 600-700. So we kind of want to call a conference which will be between more like people who use SIP and the developers. So it will be like 50-50 open source and maybe a few presentations from business people too. So yeah, and then we can also look at some of the stuff like interrupt testing, but that's maybe for some later years. So yeah, basically it's kind of like, and then next year I'm interested. There is FIFA I think tournament here in Vancouver too. So the idea here maybe make it a little bit before. So if somebody follows football, it can also attend.
That would be
Dima,
nice.
Dima, do you have those slides, by the way? I think Dima got some preliminary design. Yeah, kind of. Yeah, there was no really SIP events in Canada, so it's kind of trying to fill that space, and I will have few customers here who are kind of interested too. Yeah, we stole shamelessly some pictures from Janus Con, I think. So I guess the question is, do you guys, if we do it, are you coming? At least tentatively.
I'm in Canada and I can come.
All right. We got first volunteer.
But on the other coast, it's a bit far.
Oh yeah. Well, the flight.
Well, next year seems reasonable for me. This year is not.
Yeah. Next year, obviously, we're not talking about this year, but at least hopefully we'll get through with the announcement. So help us with like some sharing and likes and all that.
Yeah,
I
definitely.
would definitely appreciate. And yeah, if you guys want to come, and it would really happy to have you here, and kind of especially if you come with some presentation, always it's great. And we're looking at doing like organizing some social activities in the area. That would be interesting. So especially if you have not been in this. Have you been to Vancouver, Sandra? Or maybe he stepped away.
Not yet.
Not yet. All right.
Was there an invite?
Always. You can come any day.
Yeah, sounds like a good idea. When is that?
But looking about next summer, somewhere in June, July time. So I think it's for British Columbia, I think it's the best, in my opinion, best time of year to come. We pretty much don't have any rains, and usually the weather is kind of nice and warm, even hot sometimes.
Yep.
So yeah, definitely. And as I said, if you're a football fan, next year will be big. Do you guys watch football?
Not me. Guys,
Not you?
I guess I fixed my screen sharing and I can
Oh
share
yeah,
a
yeah.
picture. It will give you a better understanding of the idea. Can you see my screen now?
Oh yeah.
That's basically the concept I mentioned. So if we have data about the packets that we received to closed ports, we can calculate the ratio between good and bad packets. Like, because if somebody constantly sends packets to the closed port, probably by default we assume that it's a bad guy, and we can calculate the ratio, and after some threshold, we know for sure that this is not an our user but an attacker. And with Asterisk, we cannot do that because Asterisk doesn't have a kernel module. But with the RTP engine, I believe without even opening the ports, we can understand who is sending the traffic there. So that was my point.
Yeah, makes sense. But as we discussed, the main problem here would be to make this
A lot
reliable
a
and
lot of
robust.
problems. Like when you start implementing something like that, you have a lot of
Yeah,
problems.
but here not only that. Here you have like fundamental issues with yes, mentioned straight packet will come for number of reasons, like some protocol not closing. Sometimes it will be delayed closing on one end, so you still get. And then just the nature of UDP, right? It can get corrupted. So sometimes you might get just normal stream, nobody doing anything weird, and then some bit got corrupted and it's not detected by checksum. So
Yeah, it's not like a silver bullet. It's just another layer of protection. It's somebody can use it. But
To me, it sounds like a great way to have a presentation at one of the RTC conferences then, and you will talk about all the interesting and weird things that you detected that you previously had no idea were right to your media servers or server IPs at least.
we have a proof of concept. When we put it in production, I believe I will have a lot of good ideas when it's not working.
Exactly. I mean, if you're doing it as an intrusion detection system, not a prevention system, it's kind of only a matter of wasting time looking at the logs, but it's when you start automatically blocking, it's when it gets tricky. I mean, problematic.
Yeah. And then you start getting night calls from customers.
I mean, the reality is, I don't know of any security solutions, at the firewall sort of stuff that works for media, really. And there are good reasons for
mostly
that.
because of the architecture and not like those two pieces together doesn't work well.
Exactly. But yeah, it's definitely an interesting thing, and if anyone is implementing these sort of things, I would love to hear about them. Because we don't have that
in production, we can create a prototype, and I will pin you and let you to touch it if you want.
Yeah, I mean, we can definitely test it so that you see that it's actually detecting what we do in our own way. You would be using your own tools, of course, to test it out, but yeah, it's good to exchange on solutions, because we we focus a lot on attack, but we need help when it comes to detection and prevention and solutions, because you only can give good solutions when when you have the real networks, where you have the real users, and then you know if it's a real properly a good solution or not. A good solution is one that does not impact your users.
Yeah. That's the first thing, even
Yeah.
before protecting.
One interesting idea for you, Sandro, maybe on for your next presentation of the matter. I guess you can build a little call it internet scanner, right? You can build. You already have some of that in your toolbox, but something that can run pretty much forever. Like that SIP scan, I guess, but for RTP Bleed, right? So you can build a whole list of because the internet is not that big; it's only 32
No, you
bits,
can
right?
definitely scan the internet in a very short time, but I wouldn't do that for RTP because it causes denial of service, right? So
Don't help them. Just don't help them.
Yeah, but
Yeah.
you don't need to do. You don't. Obviously, you will disrupt some traffic. But,
you will. It's the nature of the attack is denial of service
yeah.
most of the times.
Yeah, but if you only scan one host, and I don't know, you can
The-
scan
the-
one port at a time.
Still,
It's obviously.
Let's say we haven't been doing any internet scanning since a long time because you
Okay.
get abuse emails immediately, and we're running a very legitimate business here, and we find it very problematic to have a bad reputation.
Okay. Interesting.
It's interesting for research purposes, of course, and I
Yeah,
have
that's what I'm
a
talking
really
about.
old presentation. You can find it in Sweden. In Sweden, I think I gave it at, at a security conference where I spoke about what you get when you scan SIP back then, and there were all sorts of interesting devices and so on.
Yeah, but now the stakes a bit higher. As I said, we know there is this stuff runs in kernel mode, right? So yeah, if you break it out of sudden, you might find out that there is I don't know, a few thousand of uh, you know huge systems that you can take down. Uh, yeah.
Yeah. We haven't found any problems with the kernel mode of RTP engine, but we didn't specifically look as well. So we just never broke it while doing dumb fuzzing sort of stuff.
Yeah.
So I think that the kernel
Yeah.
code is relatively not doing too much logic there. But maybe I'm misspeaking, so don't quote me. No, it's all.
Not. Yeah. Okay. All right. I think we're kind of more or less good for the day, unless somebody has any other interesting topics for discussion.
Not football.
Yeah, I'm not a big fan. I was just thinking, you guys from Europe, you must be football.
Oh yeah, normally people from Europe are into football, but it seems it's the wrong crowd. That's fun. What about football?
I used to play. I used to watch. Not anymore.
Yeah.
Not anymore. What happened? You just got old.
My second son was born, so
Second son, but it's
yeah.
he will be
I
grown
can
up
talk.
in just 10 years.
Watch the first one playing football. That's all I can get.
Yeah, but also you're still kind of on the hook for that.
Yes, I used to play and I love football, but if I come to Vancouver, it would be nice to see a live football match after, I believe, 15 years, nah, 10 years.
Oh, you have not been out for a long time? Wow.
Well, on a football pitch, I've been out for let's say, Romanians games or Champions League finals, something like that. But watching TV is not live.
Yeah. Is Tudor playing?
Yeah, he started.
Started?
Yeah, he started. He's almost 3 months now, so I get to see soccer while he plays. But that's all I can get.
Yeah. My son, my middle son, really likes football. Actually, I brought him one of those hoodies from Amsterdam. It's like Holland, and
Oh,
yeah,
nice.
he wears it all the time, so kind of nice. So.
Yeah, so if you can arrange an activity, I will get my boots and.
Yeah, I'm not a player myself, but yeah, I can find somebody to play with you definitely.
Well, the idea is to play all of us playing.
All of us. Okay. Well, I will not be much of use, but I can try. For kicks.
Uh, Football or soccer is nice.
Yeah. All right. Well, I guess we can wrap up on this topic.
Yep.
Well,
Sure. Thank you guys. Thanks for
yeah,
joining.
interesting
And
discussion. Yeah, thank you for Sandro for coming out, and yeah, keep pushing the shit, improving stuff.
For the invitation.
Takes time that somebody like Squeaky agrees get the wheel right, or grease, right? Squeaky wheel gets the grease, but that's the right one.
Thank you very much, guys.
So hopefully it will improve over time. Thanks everyone for joining in, for tuning in, and yeah, we'll be back in a little while.
yeah, definitely.
Bye.
Thanks for joining.
Thanks,
Have a
everyone.
great evening.
Bye.
Bye.
Bye, guys.
Thank you. Bye-bye.